Hello, my name is Daimara Gonzalez Pinedo, and my final project is titled Multimodal RAG for drug-drug interaction and safety drug assessment. And this project is we're trying to build a clinician-facing evidence support prototype that it's meant for asking questions and getting answers on drug-drug interaction and drug safety. It is not for the use of a patient, and also it hasn't been validated. The main motivation for this project, behind this project, is, well, one, clinicians are always in the need to having to look for and keep on top of the newest discoveries and research and clinical trial results. And now with AI and autonomous scientific discovery and using AI for drug discovery, this is going to get worse. There's the corpus of the new information that is coming out is huge, and using Google is time consuming. And we know that general LLMs can hallucinate. So not only I want to build a multimodal RAG that gets information from different sources and synthesizes the evidence from structured information, etc., to generate this output, but also verify the answer and give the trace of where this is coming from. I use two basic cases. One is drug-drug interaction. If I'm taking this medication, can I take this one? And condition safety with drug. If I have this condition or this disease, can I take this drug? Is it safe? Before I get into that, I want to talk a little bit about the tools and the data sources. So I use the drug bank style as a CSV data source with the different drug interactions, and has the relationships between drugs. And then you have a code that tells you the label, leads to the label of the drug that I am inquiring about. I've used this OpenFDA and DailyMed database. Provides, again, drug label information, warnings. Now they have warnings, contraindications, adverse reactions, and drug interactions. Also, it provides information about over-the-counter drugs. The RX norm here, it's meant to normalize drug names, because we don't want any ambiguity between genetic names and brand names. Then the PubChem PubRes is what I use to retrieve the molecular structure information, including molecular formula and weight, etc. But also there's the image of the actual drug. And I wanted to use it in a different way, but I ended up converted this into image-derived text evidence, so it could be searched within the RAG system. And then I also added a very small pharmacology biochemistry corpus that I wrote for just a few rows. And in the future, the concept is that you'll have this huge encyclopedia of all this information in a dictionary type of form that can also accessed by the RAG. So the build the I think I have to come back here. So the system works like this. We have a question of drug condition safety. Then it basically builds a raw evidence package after that. So first, you get is it a drug or a condition? You extract this, then you normalize the drug name. It's always going to have a drug. The query is always going to be associated with the drug in this case. So you have to normalize. Then after that, the system builds a raw evidence package, which is just a dictionary that stores the user question, the question type, condition, or drug. and then extracted information, drugs, condition, all the evidence from the drug bank, open FDA, all the evidence from the daily med records, the PubChem metadata, and any support context, right? This is just raw information, raw data. It's like a container. Then the system will convert this into chunks that can be actually used. The PubMed molecular image becomes text, actually. And this is the way that I built it because it's the future will be having image from MRIs and PET scans that need a little different way of being dealt with. Then after the FAISS retrieves the information and creates this fusion layer. I used it for this. Think about the FAISS retrieval as you go to a library and then this is the person who goes and gets the actual book and tells me what is the most important or similar to the query. I used a K6. It's an arbitrary number. I really don't know what would be the best number. Need more research on that with the time that I had. I just saw that it worked. But if I'm not mistaken, and it is in the, now that I think about it, it's using cosine similarity in this case. So after that, there's this evidence fusion layer that puts everything together into a clean context that the LLM can actually use. And it preserves the source labels, the modality labels, and the retrieval scores. And then the first LLM, which is OpenAI in this case, generates the first draft or the draft that the clinician is going to receive as an answer. And then you have a second LLM. In this case, I use Claude. I had this idea that this LLM can be involved acting as a verifier and check whether this draft or this answer is supported actually by the retrieved evidence, the evidence that we have here in this fusion layer. Then if it passes and it's supported and it's acceptable, it goes and you will see that it says that it's passed. Then you have another block or another, there are like 3 different categories. The second will be revise. So it will tell me something like, no, this is really not great. You have to go back and revise this. And then the next one, and I'm sorry, I forgot to move the slides. It's this block. It says it's unsafe, it's contradicting, it's unsupported. You should not be really use it. And then the model will mark this as a hallucination. So you'll see in the output later. And then I wanted to create a hallucination audit registry that it could be used later for analytics. If it's flagged as a hallucination, it'll go into this log. At the beginning, it didn't work great. It took a few tweaks, but it's still not working 100%. Maybe I'm missing something in my code for this to be, but it would be awesome if we always have a second layer telling me, oh, this is the model is starting to hallucinate. This is not the data that came in. We have to do this again, or let me go and get this information again. This is an example. The first example is drug. Okay, drug. I used was warfarin and ibuprofen. It's very common. It's like very straightforward. So you can see here that the system. But you first can see actually the sources that the system used. The drug style interaction edge table returns a structured match between these 2 drugs. And it tells me that there's a bleeding risk evidence. The system says it's high alert because bleeding risk evidence. It says it's highlighted. It's probably in my the way that I set it up. Probably it could be changed. This could be changed. That's why the input of domain specialty it's important in this type of work. We need the human in the loop. And then the system also says that we need to revise this. For some reason, it comes as a needs to be revised. The second is testing a disease, kidney disease, with a drug. It tested as alert severity high. So the system will extract the ibuprofen as the drug and the kidney disease as the condition, and then the open FDA safety extraction functions to include if there's any over-the-counter. This is an over-the-counter medication, so that's when it becomes useful. Then the verifier here flags it as it says it's true that this was logged. I believe it's because it's not giving me information about the interaction. So it says that you need a physician consultation. Maybe it's because it's not in the corpus. So it says generally not recommended. The verifier tells you need to revise this information. It's uncertain. There's no confidence. There are other examples in the report that you will see that it works in other cases, but this is an example in which the model really didn't know what to do with this. Another case study was the prednisone and alcohol. Here it gives me information about prednisone, but it doesn't say anything about contraindications with alcohol, which I don't think that is true. So it does log it as some sort of hallucination, but the model tells you the evidence it's limited because it does not address, on the bottom you can see it does not address alcohol use in patients taking prednisone. Well, we need more corpus and more of this dictionary that I was trying to create for this to work better. But the limitations, well, it's very simple and primitive. It's not clinically validated. It is typo sensitive. I had problems with typos. It didn't automatically recommended something. I had to type the exact name of the drug. I think that the fact that PubMed Chem image is converted into text and not visually, it's not embedding this directly. It's not ideal. The severity layer is rule-based, and this top K, it's just a prototype setting. It's arbitrary. And I would like to have a verifier that completely has a full iterative self-correction loop and goes back and fix, or goes back and learns from the mistakes that this raggeds or the output gives me. So for future, I will definitely ask to would like to have a biggest corpus. I would like to have a full verifying written driven correction loop to get back and a richer radio evidence tracer. We'll add a pharmacist review and a regulatory review. So this is the project. I think I'm almost running out of time. I hope you enjoyed reading the report and the notebook. Thank you.